Hey everyone, this is Steven, StoicDev0 on Twitter. I am a Solidity dev at Remark, co-author of the AVM implementation of the protocol, together with 5 merged GIPs. This is the last video from the first project series, where I have been teaching you how I built Snake Soldiers. Remember, this is a personal project, it just happens to use Remark. In the previous video, we learned how to deploy our contracts, verify them, add some assets, and configure our catalog. In this video, we will briefly go over one of the most important things you will need to do, unit testing. I used 2 commits for these lessons since I noticed there were so many tweaks needed on the scripts in order to reuse them for tests. Let's take a quick look at the first one. Most of the change was simply replacing these assets so they were big numbers instead of regular numbers. I have a utility function I use a lot, which is a shortcut to this function call. I'm also defining a variable to identify if I'm in prod, which will be only true if the network is currently Moonbeam. Also added some new constants I was going to need. I'm changing the price for testing, so I can easily test this with the tokens on the testnet without having to spend so many of them. Same change here, moving things to big numbers. This will be very useful for testing, since when you send transactions, it's fine if you send either numbers or big numbers, but when you get the results, it will always be big numbers. So when you're doing the comparisons, it's easier if they are already big numbers. Made some change here as well. This will receive now either a number of big number for Snake ID, and fixed parts will always be big numbers. And I'm exporting the write function, which will add a full asset to a single snake instead of the test one I showed you previously. In the Snake catalog, I'm importing the equip render utils. Even though I won't use it in this contract, it's a simple trick so it gets detected by typechain and I can use that type in the tests. Then I did some minor changes on the deploy script. This will no longer run, but define a function to run, and will have small different behavior whether it's called from testing or not, mainly console logs and trying to verify the contract. And since this won't run, I created a run script which will just call this function. The second commit will contain all the tests and config we will see next. We start with a few imports. We will be using ethers, expect is for assertions, and I really like using TypeScript since it gives you auto-completion and easy error detection, so I'm importing the type for assigner. I'm also importing several constants, the same that will be used in production. And from typechain, I import the interface of each of the contracts to take full advantage of TypeScript. Next, I'm defining a fixture. Fixtures are an awesome tool because basically whatever state you set the blockchain into will be sort of remembered. So every time you call this, it will simply restore it instead of creating it from zero. This has a huge impact on the time our tests take to run, and it will be very noticeable when we have a large test suite. Here, I'm using the same method to deploy the contracts. I'm simply deploying an additional one for the render utils. This is the same we will be using in production. What I'll show you here is how I do testing. There are probably many alternatives or best practices, but I want to show you what has worked for me after writing literally thousands of lines of tests, so you have a place to start. I'll start by defining all the variables I will need, especially contracts and signers, each of them with the right type, and then I will do a before each where I will set the initial configurations that will apply for each of the tests. So this code here will run before each test that's defined after that. I usually start with the failing tests. Typically, you will check many conditions, so it's common that most tests check what cases revert. Make sure when you expect a revert, you check the expected error. When using custom errors, you need to define the contract raising the error, which may be different to the one you're calling if it does external calls. I'm leaving notes throughout the test so you can more easily check the details later. The thing to note here is that we can connect as other users. By default, it will use the first available address, which is usually the deployer. We get them all here using ethers.getSigners. For the success case, I don't specify the signer since the first address is the contract owner. Now notice that in some cases, the expect goes before the await, like this. And sometimes the other way around. Why is that? When I want to check the result value, the await must happen inside the expect. So the result is retrieved before doing the assertion. This is also the case when we will check our immediate events. When we expect an error, the await needs to go behind the expect. Otherwise, it would raise the error before checking. It's a bit unexpected in my opinion, but just be aware of it. Next, we create a new describe group. You can nest them to continue creating the needed state for the test on top of what's already set. It's very useful to avoid code duplication. I did not enable the next phase on the initial before each, since I didn't need it, and I wouldn't be able to test minting with no phases opened, which I do here. We have two simple failure tests here, trying to mint 0 snakes, or sending the wrong price. For instance, buying a general but sending the value of a soldier. In case you're not familiar with ethers, this is how you send native token on a method call. Two things to notice here. First, when you have multiple versions of a method, you need to call it like this, otherwise ethers will complain. The second is that whenever possible, I'm using constants or getting the values from the contract instead of having a random value here, which I will forget later why I used in the first place. So instead of setting the max supply for generals equals to 5, which I know at the moment but may change or I may forget, I get it directly from the contract. Let's see some anti-rug tests to protect holders. We check that if we lock the phases, in case some phase didn't sell well, no more phases can be opened. We also check that no more than 4 phases can ever be opened, ensuring the max supply of 5,000 soldiers. And also check that the next phases cannot be opened with a lower price. This check I do for each of the ranks. We do some access checks. Only owners should be able to do each of these operations, lock phases, and manage assets with all it entails. I won't go into detail. And here I confirm the advantages of unit tests. Somehow the gift mint function we saw on lesson 6 was not included in the code. I only realized when I was writing this test. Also a good reason to write tests in parallel with the code, or even better, before the code as recommended by test-driven design. For the purpose of these tutorials, I felt it wasn't practical. We checked that only the owner can mint gifts with a failure and a success case, and also check that no more gifts that configure and deploy can be sent. Another anti-rug measure. Again, instead of using a number, I use a constant. One cool feature is that you can use .skip to skip a test or a group of tests, and similarly with .only to run nothing but those marked. For the next group of tests, I will run some snakes for the 2 buyers. When the tests start running, each address has a balance of 100 of the native token, so no need to worry about it, but if you ever need to change it, you could also do it. We check for token URI, which we programmed to simply return the same for each snake, simply for backwards compatibility, and then test max supply and total supply. Although these are very similar tests, I prefer to have them separated. In case something fails, we know exactly what it is. Remember, we created versions for these two as a global and per rank. Let's stop for a moment to check the coverage, which we can do with a simple command. Coverage is a great tool to make sure you're going through all the code with your tests. This extension generates a nice HTML page with the results. It will show you by statements, branches, functions, and lines how many of them you got covered, and you can navigate through each of the files. Let's take a look at Snake Soldiers, which is the one we're testing now. You see that there are several things still pending the test. All this is covered, and we haven't tested the withdraw raised and the reveal element. So let's do that next. Going back to the code, there were also some tests missing for asset management, which I'm adding here but won't go into the detail. Adding regular assets, enumerated assets, both setting and unsetting, equipable assets, and setting a valid parent for an equipable group. Now let's test some of the very specific logic we have, the egg reveal. I'm doing the test for each rank, making sure it initially has the unrevealed version, and then the one with the right element. I'm using render utils to get a more complete data in a single call. Here. We will see it more in detail in another video. I simply call reveal element each time and then compare the expected as it is in place. We do it for generals, commanders, and soldiers. We also check that the owner of the egg can reveal it, only the owner. If I connect as another user, I won't be able to. And that you cannot reveal the egg twice. Just two more things I want to check. First, the claiming of the gems, because it is another custom functionality we focused in. I'm doing a few checks in a single test since it's the same setup, but ideally I could create a group with a before each and then independent test for each of the check. I'll claim each of the gems. They will all use the same asset with an ID of 1, but the metadata will change according to the type of gem, which is defined with some heuristic we saw in videos 7, 8, and 9. Check that they are marked as claimed and that the snake has them on dependent children. Finally, I check they have the expected metadata. In the case of the token ID 1, it is the general which should receive a matching set of gems, namely Earth as element, Mountain as faction, and Tank as skill. Lastly, we make sure that only the owner can withdraw the funds and that they are sent correctly. A last trick here is to withdraw through a different address, which is not the color, so you can easily compare the expected balance without worrying about the gas spent by the transaction itself. If we take one last check at the coverage, it's looking great for the Snake Soldier contract. Before we go, there's a cool thing I want to show you. Gas is an important factor on blockchain. We want to make sure we are not doing things which are too expensive, even if we're working on layer 2s or other cheaper chains. As my friend Zikata used to say, gas on Ethereum was cheap until it wasn't. Luckily, there is a tool which can help us with this. We use it often when building the protocol to detect the best coding patterns for gas. We need to add some configurations, one on Hardhat and another one on an environment file. The template already includes the installation for the package, which is Hardhat Gas Report. It will be enabled depending on an environment variable, this one. You can set also the currency and the token, and ideally you should get a CoinMarketCap API. You can get it here. They have a free tier. You can also set the gas price API for the token you want to use. There are some more options on the link here. With our environment vars set, we run yarn hardhat test. The result won't show when using coverage. With this, you will be able to see how much gas each of the operations took and the equivalent in the currency you set. It also shows you the minimum and maximum for each. With this, you can do tweaks to your code to find cheaper ways. With that, you can check that, for instance, this log pattern we use on Snake Soldier is the cheapest. Once the test finished running, you can see for each of the methods which affects the state, what's the average, min, max, and number of calls. The last column will give you the price on USD. I'm using Glimmer here, Moonbeam, as test. That's it for the video. I really encourage you to write tests for your own contracts to avoid surprises. I must warn you that the coverage itself won't guarantee that your contracts are free of errors. There could be specific paths which trigger issues and are not caught by coverage, since it looks for the execution of each possible piece of code, but not of each possible combination of steps. With that said, unit testing may prevent most problems, so it's highly worth it. That's also all for this series. I hope you enjoyed it and feel ready to start building. If you liked it, please subscribe and share with other EVM developers. See you on the next series. You can also support by following the Snake Soldiers on Twitter. We will be minting soon. Thanks.